Data centers shift on-site as AI strains power grid capacity. Artificial intelligence is adding another layer of pressure to an already strained data center infrastructure market. Developers are seeking larger amounts of electricity while also managing cooling requirements, water availability, and lengthy utility interconnection timelines. Energy Concepts, an energy technology company based in Rochester, New York, is targeting those constraints with Plato 5X, a modular platform designed to provide on-site electricity generation alongside cooling, water recovery, and carbon capture. According to the company, each 5-megawatt module can produce 5,000 kilowatts of electricity, approximately 12,000 gallons of water, and about 11,000 gallons of food-grade liquid carbon dioxide per day. Energy Concepts also reports that the platform can capture more than 90% of the carbon dioxide produced during combustion. The figures point to a broader question now facing the data center sector: how much supporting infrastructure can or should be moved directly onto the data center site? On-site generation offers another route around grid delays. Plato 5X combines natural gas cogeneration with absorption cooling, carbon capture, and water recovery within a modular system. Energy Concepts says the configuration is intended to allow facilities to meet core power and cooling requirements without relying on grid electricity or municipal water. That approach comes as access to power increasingly influences where data centers can be developed. In established and emerging data center markets, transmission limitations, generation shortages, and long interconnection queues can extend project schedules well beyond the construction timeline for the facility itself. On-site generation could provide developers with another option where sufficient utility capacity is unavailable or where network upgrades would delay a project. It could also shift some responsibility for critical infrastructure from utilities to data center owners and third-party energy providers. However, Plato 5X remains dependent on natural gas. Carbon capture could reduce emissions associated with combustion if reported capture rates are achieved consistently in commercial deployments, but the technology does not remove fossil fuels from the energy mix. Its overall emissions profile would need to account for factors such as methane leakage across the natural gas supply chain, system efficiency, utilization rates, and the handling of captured CO2. These considerations are likely to be weighed against a growing range of alternatives, including utility-supplied electricity, renewable power agreements, batteries, fuel cells, and other distributed energy systems. Reliability will also be central to the business case. Data centers require high levels of uptime, meaning any move towards self-supplied power must provide sufficient redundancy, maintenance capacity, and backup options. Water recovery and carbon capture. Expand the infrastructure equation. The platform is also designed to make use of resources created during power generation. Waste heat is directed toward absorption cooling, while water recovery is intended to reduce the amount of outside water required to operate the site. Energy Concepts estimates that a 100-megawatt deployment consisting of multiple Plato 5X modules could generate up to 240,000 gallons of water per day. Water has become a more prominent issue in data center development as large campuses expand into markets facing pressure on municipal systems or groundwater supplies. Recovering water on site could reduce some of that demand, although the extent of any reduction would depend on local conditions, treatment requirements, and how the recovered water is used within the cooling system. Carbon dioxide represents another potential output. Energy Concepts says captured CO2 can be processed into food-grade liquid carbon dioxide. Based on company estimates, a 100-megawatt installation could produce as much as 220,000 gallons of liquid CO2 per day. Selling that output could potentially offset part of the system's operating costs, but the commercial case would vary significantly by location. Regional CO2 demand, transport distances, purification costs, and available storage or end-use markets would all influence whether captured carbon becomes a viable revenue stream. The modular format is intended to support deployments ranging from smaller edge facilities to larger data center campuses. Energy Concepts also says the energy infrastructure can be financed, built, and operated separately from the computing facility itself. For developers, that structure could create an alternative to owning all power and cooling assets directly. It may also make third-party infrastructure providers a larger part of future data center projects, as developers look to reduce capital requirements and manage energy-related risk. The larger trend extends beyond any single technology. As AI computing requirements rise, data centers increasingly have to solve energy, cooling, and water constraints at the project level, rather than assuming utility infrastructure will be available when required. Whether systems such as Plato 5X gain widespread adoption will depend on permitting, economics, natural gas availability, equipment performance, and life cycle emissions. But the market pressure behind them is unlikely to disappear. Power infrastructure is becoming a core part of data center development strategy rather than simply a utility connection made after the site is selected.